So today we're going to, again, work on looking at graphs in a real world setting, like the typical problems like Johnny has 4 apples, blah, blah, blah type of questions. So let's take a look here. So the graph shows how the number of salad plates that Porter has left is related to the number of tables that he has set. Okay, so when looking at these problems, you want to make sure you are paying attention to what's the x and what's the y. Like what's on the x-axis and what's on the y-axis. So on the x-axis, these are just the number of plates, and the y-axis says the number of salad plates remaining. So this guy is cleaning up tables probably at a restaurant or at a convention or something. So let's see. If I had 10 tables left, if I had 10 tables, I would have to clean up 70 salad plates. If I had 20 tables, I would have to clean up 60. So the graph shows the number of salad plates that the porter has left in relationship to the number of tables that he has set. Oh, other way around. He's not cleaning up, he's setting up. My bad. So at 0 tables, if he hasn't even started, he has 80 salad plates to set out. If he did 10, he has 70 left. If he did 20 table already, he had 60 salad plates left. And once he's finished all 80 tables, he has 0 salads left. So you have to tell yourself a story every time you look at these types of word problems and tables to try to make sure it makes sense in your brain. You can't just start clicking or guessing because it really is just a waste of your time. I can't stress, like, understanding the situation is part of the math. Have you ever told your parents something and before you even finished the story, they started to give you suggestions or they thought they knew what you were saying already? And that's the thing about these math problems. You don't want to do that to these problems because you, in the end, get confused or get them wrong. So let's go ahead and look at this again. The graph shows the number of salad plates that the porter has left in the number of tables that he has set. So as I set more tables, I have less plates remaining. So if the porter has set 40 tables, how many salad plates will he have left? So here are our tables. So I walk up. So he has 40 salad plates left. So we mentioned the idea of functions, and these graphs are based on some type of function, like some input and some output. So the input here is fish sold, and the output is fish remaining. So if we start off at 0, if I have 0 fish sold, 0 fish sold, that means I should have 4 fish remaining. So he has a total of 4 fish to sell. If he sells 1 fish, he has 3 fish remaining. If he sells 2 fish, he has 2 remaining. If he has 3 fish, he has 1 fish. And if he sold 4 fish, he has no fish remaining because he sold them all. So that's the relationship of the graph. So let's read what the setup is. This graph shows how the number of fish remaining in Maddie's fish tank depend on the number of fish she has sold. So the prompt is, how many fish must Maddie sell in order to have 1 fish left in the tank? So if she wants 1 fish left in the tank, so look, these are the fish remaining or the fish sold. So did they give us the fish sold or the fish remaining? Read it again. How many fish must Maddie sell in order to have 1 fish remaining? So how many must she sell if she wants only 1 fish remaining? This is the fish remaining column. So she wants 1 fish remaining, she must sell 3 fish. So each of these will ask you to go either looking at our Y column or our X. So that's the thing about these problems. It's that sometimes they go this way first, and then it makes you come out to find your X value, or they give you x value to find y. So let's go ahead and look at this question here. How many weeks of lessons will Jeffrey need before he will be able to sing a total of 60 pieces? Okay, so they gave me the information was 60 pieces. This is not 60 pieces. This is number of weeks. Pieces are over here. You guys have to get 80. 80, okay? So if we're looking at pieces, that's 60. So how many weeks does he need? He needs to get 50. Now, if you misinterpret this and you thought 60 was the number of weeks, you could be up here and you'd be like 63 or something. But please read the question very carefully. It's a very common mistake when we just assume to know what we're talking about. And in this case, this wasn't 60 pieces, sorry, 60 weeks, this was 60 pieces. So the relationship, at 60 pieces, it would take her, or Jeffrey, 50 weeks to learn 60 pieces. I'm gonna click 50. So, okay. So this one isn't the hard one, okay? But it is a little tricky because you have to make sure you read what they want. In this question here, if Kurt sets 3 tables, how many napkins will be left? So these are tables. Is tables my y or my x? Tables, no, 3 tables. 3 tables is over here, the x-axis. At 3 tables, how many napkins remain? They're going to be 4. Thank you. And that's the cool thing about these graphs. They tell you all the information you need to know. They're not just dot points, but even in between. So we can say 4. Okay, so this is pretty easy. I did like 4 questions. I'm already at 36. So the next IXL we want to talk about today is 15. And interpreting functions using everyday language. Now this one is a little more wordy, but please take your time reading this and think of yourself in that situation. Usually when I read word problems, instead of saying, for instance, I try to put myself in that situation. So let's go ahead and read the prompt. The All Clean Laundry Company washes towels for a nearby hotel. Okay, I've been to a hotel anymore, so I'm trying to understand that. So someone washes their towels. The function f of x gives the number of loads required when there are x bins of towels to wash. So x is the number of towels, and f of x tells me how many loads of laundry I'll need to wash those towels. So let's look at what they told us here. So they said f of x, x is the number of towels. So instead of writing x, they wrote the number 9. So that's 9 towels. F gives the number of loads required. So to do 9 towels, they need greater than 12 loads of laundry. So again, let's look at that again. X is the number of towels. So if I plug 9 in, it tells me how many loads of laundry do I need. So I need greater than 12. So let's read the 2 options. It takes more than 9 loads of laundry to wash 12 bins of towels, or it takes more than 12 loads of towel. It takes more than 12 loads to wash 9 bins of towels. So go ahead and read these. I'm going to give you guys a quick poll, and you're going to tell me if it's going to be yes for the first one or no for the second one. Which one do you think it's going to be? Yes or no? So if you think the answer is the first one, please click yes in the participants window. And if you think it's no, go ahead and click the second one. So this will spit out, this answer here is the number of loads of laundry. Remember we did that machine, the function machine, where we would plug in a value and it kick out an answer? This is what this function does. You plug in the value and it'll kick out an answer. So what value am I plugging in? Well, X here is a number of towels. So if I plug in 9 towels, this is 9 towels, the answer is the number of loads of laundry. So to wash 9 bins of towels, it would take me more than 12 loads of laundry. So the answer is actually the second one. So let's read them again. It takes more than 9 loads. Wait, I wasn't dealing with 9 loads. What was I dealing with? I was dealing with wait, whoops. Sorry, I was dealing with 9 loads. How come this one won't let me touch? Okay. Yeah, I was dealing with 9 loads, and then it would take me more than 12 loads of laundry. Wait, I was dealing with 9. Dang it, I messed myself up. I wasn't dealing with 9 loads. I was dealing with 9 what? Bins of towels. That's what X represents. So it's actually the second one. It takes more than 12 loads to wash 9 bins of towels. Let's look at the next example. Anne is the president of her school's engineering club, and she's ordering t-shirts for her club members. The company she's buying from charges f of x dollars per shirt. So f of x here is how much money. F of x here is how much money, right here. That is dinero. That's money. For an order of x shirts. So x here is the number of shirts. So let's read the function, or our little example here, equation. What does f of 25 less than 10 tell you? So 25 was the number of shirts. And the function overall, wasn't that how much money we have to pay? So for 25 shirts, I would have to pay less than $10. So let's read the 2 prompts. The company charges $25 per shirt. But is that what X was? No, 25 was the number of shirts I needed. And the function, the answer to this is money. So it's actually the other one. The company charges under $10 per shirt for 25 shirt order. Okay. So be careful when you're reading it, and the prompt gives you clues of what each thing means. F of X here meant dollars, and X meant shirts. So when I plug in F of X, which was F of 25, that's the number of shirts. Let's look at another example. In order to raise money for the school dance, students in leadership class are collecting cans to recycle. Okay, I can see that. We actually did that at Hamilton. When they recycle X bags of cans, they receive F of X dollars to put toward the dance. So let's see what F of X stands for. F of X stands for money, and X is cans, bags of cans. So what they gave us was F of 20. What does 20 represent? Does that represent the money or the cans? Remember, F of X, we're plugging in X, and that's giving us money. So X here, which is now 20, that's the number of cans. And they say if you turned in 20 bags of cans, they'll give you 60. What is F of X? $60. That's money. So students can make $60 when they recycle 20 bags of cans. Now, why do you have to practice these word problems? Because I can't stress standardized testing, the SAT, have word problems like this. And as we go more to algebra, we'll see more word problems. And word problems can be a little like brain twisters, right? Like you have to make sure you're paying attention. In the spring, Liz planted sunflowers in her backyard to keep track of how tall they are. The function f of x is their height in inches x days after they are planted. So x represents days, and f of x represents heights. So for this function, f of 90, what does 90 represent? 90 is the height, or is it the days? Hopefully I see the pattern already. It's f of x, so we plug in the x. In this case, we plugged in 90. So we have f of 90. So these are the days. And the function tells you the height. So at 90 days, what's the height? Well, the height here is going to be bigger than 55 inches. How do I know it's inches? It was actually in the prompt here. So f of 90 means f of 90 days. Well, f is the height. So the height is greater than 55 inches after 90 days. That's going to be our first prompt. The sunflower are over 55 inches tall 90 days after planting. Okay, so IXL responds on how fast you answer, as well as your correct answers, okay? So we're going to do one more today. And that last one is actually the one where we need the most math. The other ones are just really reading, but this rate of change is, I think, one of the trickiest. And it's going to lead us to what we call slope when we graph lines. So let's go ahead and read the prompt, and then we'll try to answer what they're asking about. Okay, Austin closely monitored the balance of his checking account. So let's take a look at his checking account. So we have June, July, August, September, October. And his monthly statement said he had 78, 93, 74, 97, 84. Okay, that's how much he had. He saved some more, he spent a little bit more, depending on the month. According to the table, what is the rate of change between August and October? Now, the rate of change is a fraction, something over something, okay? It's something over time. And in this case, this is dollars over months. A rate of change is, for instance, miles per hour. If you ever see the idea of miles per hour, it's if I drive 3 miles per 1 hour, after 1 hour, I drove 3 miles. But what happens if I drove 2 miles? Sorry, for 2 hours. 3 miles over hours. If I drove for 2 hours, here's what we do. Multiply the numbers together. 3 times 2 is 6. And look at the words. What's hours divided by hours? They cancel out. Leave me just miles. So the rate here they're going to give us is, according to the table, what is the rate of change between August and October? Let's take a look at August and October here. So we're going to go ahead and see they want dollars on top per month. When you see the word per, it's another way of using a division sign. So it's dollars on top per month. So let's set this up. How much money is between October and August? October was 84 and August was 74. How many months did it take to get between August and October? This is 2 months. 2 months. So how much was the rate of change between August and October? 80 minus 74 is 10 over 2. It's 5, because we can reduce, $5 per month. Now, in essence, this is the average rate. It's not exactly 5. Let's take a look at the table. To get from 74 to 80, we said, hey, that's a change of $10, right? Per 2 months. But does that mean they grew $5 every single time? No. So this is where averages come in. The idea of rate of change, it gives you an average of how much something has changed. So in this case, right, 74 to 97 is huge, but then he loses it all. So all his gains became loss. So overall, he gained $5 per month. So we go from month to month, average of $5 per month. So 74 becomes 79, becomes 84. So let's do another example of this. So here are the goals of finding rate of change. You find your end, find your beginning, and we divide by the time. Let's do that again. So make sure you are paying attention to this lesson. This is the one that's a harder one. Okay, the drama department recorded how long the annual school plays lasted each year. Okay, so depending on the year, the school plays varied in time. Sometimes a little bit longer, sometimes a little bit shorter. According to the table, what was the rate of change between 2008 and 2010? So 2008, oops, 2008 and 2010. So you pick your two dates to compare. And then they're going to say, what's the rate of change? How much did it change between 2008 and 2010? What we do is we write down our end values, 76 minus 72. We always end up subtracting over, in this case, 2010 minus 2008. So that's going to be 76 minus 72 is 4. 2010 minus 2008 is 2. Our answer is 2. But how would we format that? Well, wasn't the top number minutes and the bottom number years? So it'd be 2 minutes per year. 2 minutes per year. So to find our rates of change, what we're going to do is we're just going to subtract, in a sense, our y's, our output values, from our input values. And that's the rate of change for pretty much most of high school. They'll always go y over x or output over input. Okay, let's do 2 more examples. Just hopefully you guys can get the pattern. Okay, a pair of Richmond High School hockey fans counted the number of games won by school each year. So according to the table, what was the rate of change between 2007 and 2010? So we subtract, this is the top, and this is the bottom. Top and bottom. So we say 13, minus 16 over 2010 minus 2007. Now, is that going to be a positive number or a negative number? That's going to be a negative number. And 2010 minus 2000 is going to be 3. So the answer is -1. What does -1 mean? Well, if you look at over the 3 years, right, 3 years, how did I get from 16 to 13? We lost 1 per year. 16 became 15, 15 became 14, and then 14 became 13. So how do we interpret this? The top was games won. You can see that from just the title, and the bottom is years. So we have -1 games won per, this looks terrible. -1 games won per year. That's what they asked, this right there. So you write the topic on top divided by the topic on bottom, or per is another way for us to use that division sign. So -1 games per year. This will be -1. Okay, let's just do 2 more. We have the time. Rachel entered the amount she charged on a credit card each month in a spreadsheet. Great. Okay. So Rachel's spending is pretty low. So they want us, according to the table, what was the rate of change between August and September? Okay. So we always plug in. I mean, it's easier to do this. It's not wrong if you don't, but we'll talk about more about this later when we graph lines. But this idea of rate of change over this period, how much changed? Well, 82 minus 68 divided by September to August, that's 1 month. If you want to put numbers on this is the 9th month and this is the 8th month. 9 minus 8 is 1. But we're only looking for the difference really. And this is money. So 82 minus 68 is 14 over $14 per month. So her credit card debt increased $14 per month. Okay, this idea of rate of change is how much is something is changing over a period of time. Mr. Dawson recorded the amount that he spends on gas each month to see if it would be cheaper to take the train to work. So in August, so July, August, September, October, November, he logged it. Now the prompt is only comparing September to November. So make sure you read the prompt. So let's see what happens to his gas rate. How much is he spending extra as it's changing? So $93 minus $81 over November is the 11th month, September is the 9th month. Or you could just say, hey, that's 2 months. So 11 minus 9, or we can just say 2 months. That's also okay. Oh, that's terrible writing. Okay, so 93 minus 81 is 14. So $14 per 2 months. So this would be $7 per month. Because I'm going to reduce that. And let's see. Sure, it's not exactly $7 here. But if I go over 2 months, there would be $7 worth of change each month. 81 plus 7 is 88. And 88, whoops, I missed do the number. Oops, I did do the number wrong. It's 12, right? Oops, 12. that becomes a 6 because 12 divided by 2 is 6. So when I was checking it, it wasn't working. So 6 plus 81 becomes 87. And 87 plus 6 is 93. So made a mistake there. $6 per month. Okay. So how do you get better at word problems? Is to read them and to answer what they're asking. In this case, this is a new type of technique for us called rate of change. And the rate of change, you subtract your result over the first column, our input. Okay. And we reduce and we end up with the number of change per year. And that's our goal today.